What's up? I'm Vin, and I'm going to go through the June 2025 Algebra 2 Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. So first up, we're going through the part 1 multiple choice. There's 24 questions here, and each question is worth 2 credits. Question 1, which expression is equivalent to, and then we have 2c times the cube root of c. So for this one, the theme is power over root. We need to know that when we have something in the form of a to the b over c, that this is equal to the c root of a to the b power. So when I look at something like this, what I read this as is we have 2 times c and then the cube root of c to the first power. So I'm using this, once again, power over root idea. Okay, that's what we're going to use here. And this is going to give us 2 times c, and then times, this is going to be c to the power 1 over 3. And then the next rule to use is a to the b times a to the c equals a to the b plus c. When you multiply exponents with the same base, you add the powers together. So this is c to the first now times c to the 1/3. So that's going to give us, we're going to have 2 times c to the 1 plus 1/3. And for this, we just work this out. This is going to give us 2c. 1 plus 1/3 is 1 1/3, or we could say 4/3. And this is going to give us choice 1. Now, let's say your fraction game is not that strong. That's okay. You could always go to the calculator. You get to use a calculator at the Regents, and you could do 1 plus 1/3 and press enter, and then you press math enter enter to turn this into a fraction. So that's why we're getting 2c to the 4/3 power. Question 2, which investigation technique is most often used to determine the cause and effect of a medication? So for this one, we're going to go with a controlled experiment. So with this type of experiment, we have a control group and we have the experimental group. And with this type of investigation here, so with a controlled experiment, what happens is they have the control group, and these people here, nothing is changing for them. So maybe they're introducing a medication and these people get the placebo. So they're, let's say, taking a pill, but the pill is just nothing. Okay, it's just maybe like a sugar pill, like, a light amount of sugar, just nothing happening there. And then these people here get the actual medicine. And then they compare the results of what happens to the people in both groups. Is this medicine really doing, a lot for the people in the experimental group? And of course they would do this for something where it's not like life-saving medicine. Okay, otherwise that would be completely unethical. So that's why here we're going with choice 3. Observational study wouldn't make sense here, because you're just like observing the public without actually, altering the setting at all. In a controlled experiment, you're actually influencing what's going to happen by introducing something here. And a survey is, just self-reporting here. Census, we're just, gathering data. The controlled experiment, they're actually, once again, it's an experiment, and the experiment is to see what is the cause and effect of introducing this medication to some people while the other people get nothing. So choice 3. Question 3, what is the solution to 5 times 2 to the 19x power equals 50? So for this one, I'll do this with and without a calculator. And first, I'll just do this algebraically. So I write this equation out here. And the first thing I would do is just divide both sides by 50. So we divide both sides by 50. And now we're going to have 2 to the 19x power equals 50 divided by 5 is 10. And now if we want to solve for x and we want to get rid of this base 2 here, we could take the log base 2 of both sides. Okay, so we're going to take log base 2 of 2 to the 19x power, and we're going to take log base 2 of 10. So this is one way to go through this question. And the idea that we're using, as long as a is positive, when we have log base a of a, this is going to be equal to 1. Okay, so that's the concept we're using here. Just some, information about logs. When you have log base a of, let's say, c equals b like this, to go from log to exponent form, you could say a to the b power equals c. So a to the b power is equal to c like this. All right, so the idea is a to the first power gives you a. Like, that's why that little formula works. And that's the idea that we're using over here. Log base 2 of 2 here is just basically going to cancel out nicely. All right, if I use more properties of logs, there's another nice property of logs that says when you have something like log base a of, let's say, b to the c power, this is the same thing as c times log base a of b. So I could bring exponents in front like this. So I could bring this exponent, 19x, I could bring it to the front of the log like that. And then what could happen here, I'll just move this over. So we'll just squeeze all this stuff together, is log base 2 of 2 just cancels out as equal to 1 using this nice property here. And now we have 19x equals log base 2 of 10, and we just divide both sides by 19. Okay, so algebraically, this would be the way to get to the answer, and our answer to 3 is going to be choice 2. Now, another thing we could do here is we could go to the y equals, and we could type in the left side of the equation. So we have 5 times parentheses 2 to the 19x power, and we could type in the right side of the equation on the other side, 50. But now if I press graph, I'm not going to be able to see anything, and that's because my graph has to be able to go up to y equals 50. So I'm going to make my y maximum, let's say I go up to 100. And now I press graph, and I could see this point of intersection here. So now I press second trace number 5, and I go to the neighborhood here. Maybe I press down to go onto the red line. I get in the neighborhood, I press enter 3 times, and I get this decimal value here. So I press second mode, second answer, or I could just write that down, but that's the decimal answer for x. And if I just run through the answer choices here, so I'm going to press alpha. If you have a newer calculator, you could press alpha x, or I press alpha y equals enter if you don't have the newest TI calculator. And log base 2, I press math. Log base, I go up to see this one here, log base. And I could write in log, I put my base 2, 10 on the inside here, and then 19 in the denominator. And press enter, and see how we get the exact same decimal. If I type in the other answer choices, it's not going to match the decimal at the point of intersection here. So this is just a backup method, just in case in the multiple choice you actually are uncomfortable with the algebra, or you just want to check your answer. Question 4, the function p of t models the decreasing population of a city from 1999 to 2014, where t is the time in years since 1999. Which statement is not true? So for this one here, we just have to go piece by piece, and let's see what we could get here. So the function estimated the population was 256,485 in 1999. So here, remember, they told us t is the time in years since 1999. So in 1999, that's t equals 0, because in 1999, that's 0 years since 1999, since that's the same exact year. And if we were to plug in 0 to the function, so p of 0 equals, we have 256, 485, and then times 0.965 to the 0 power. If you type this in the calculator, you're going to get just this number here, because 0.965 to the 0 is equal to 1. So we would get 256,485, which matches choice 1. We want the statement that's not true. So this one here is out. Now we move on to 2. The decay rate was 0.35%. Now, the formula that automatically jumps to mind for me is this one from Algebra 1, when we have a equals p times 1 plus or minus r to the t power. And in this case here, since the population is decreasing, we're going to go with the minus case. So 1 minus r has to match up with 0.965. And if we were to solve this here, so I could go minus 0.965 on both sides. I subtract these numbers, so let me just make this a little neater. So we have a minus 0.965 on both sides. On the right side, now we have 0. And 1 minus 0.965 is 0. And then we'd have 0.35. Minus r equals 0, and then just go plus r on both sides. And this tells us r is equal to 0.035. But now as a percent, I would multiply this by 100 to turn this into a percent. So I could say r is equal to 0.035 times 100. And then I could throw my percent on. And the decimal moves twice, or just use the calculator. This would be 3.5%, the decay rate, not 0.35%. Okay, this is like a common mistake is, students will mix up the decimal places here. But when you're going from the rate in decimal form to the percent form, you just multiply the rate by 100. And that'll tell you that there was a 3.5% decrease. Okay, well, that's the rate of decay. The decay factor is 0.965. That is also true. Okay, that's the factor that's being raised to the t power. and the population declined over 15 years is true because the population is decreasing. Okay, so they said, hey, this models the decreasing population, and we have one of those exponential decay type functions like this. So choice 4 is something that is true, so we X it out. Definitely choice 2, that one is false. Question 5, 4 different surveys gathered data about the purchasing behaviors of pet owners. Pet owners from the same population were randomly selected. While collecting data, Chris surveyed 942 pet owners. John surveyed 410, Brooke surveyed 800, and Shane surveyed 100. Whose survey will likely have the smallest margin of error? So for these types of questions, when I'm looking for like who has the smallest margin of error, that means like whose data or research here is most accurate. Okay, so we're looking to see like who is most accurate here, because the smallest margin of error just means like the least error possible, which means more accuracy. And with statistics, when you're trying to be as accurate as possible, the key is to have a bigger sample size to collect data from more people. And it looks like Chris surveyed the most people. Okay, surveyed the most pet owners, so he is the most likely to have the smallest margin of error. So choice 2, Chris. And a more practical way to think of this, like let's say, I don't know, you went to school tomorrow and you just asked a random kid, like, hey, what's your favorite type of sandwich? And then like the kid says, peanut butter mayonnaise. Okay, so peanut butter mayonnaise is their favorite sandwich. And you're like, okay, great. That means peanut butter mayonnaise is like everybody's favorite sandwich in the whole school. Like, no, like you just happen to stumble upon like the outlier. That's probably not a common favorite sandwich among students. Like if you surveyed, let's say 3/4 of the school, just, randomly, like as kids walked into the building, you get a much different picture of what the favorite sandwich is, and something might actually come of that. But the key is you'd have to survey a lot of people to get an idea of, what the actual favorite sandwich is, at least in your school's population. So here, the bigger the survey, the more accurate. So choice 2, Chris. Question 6, given I is the imaginary unit and a equals I to the third, b equals I squared, and c equals I, which expression is equivalent to 2ax squared plus 3bx minus cx? So for this one, I would just plug right into this expression here. So we have 2 times a is I to the third. So we have I to the third times x squared. And then we have plus 3 times b is I squared. And then we have the x. And then minus c is equal to I. And we just tack on the x at the end. Now, the big idea for I is you start off with I to the 0, you get 1. I to the first power is just equal to I. But then I squared equals -1. Okay? And then we multiply both sides by I again. If we do times I on the left, we get I to the third. And we go times I on the right side, we get minus I. But then when we go to I to the fourth, I multiply both sides by I get I to the fourth equals minus I squared, which is minus I squared is -1, which brings us back to +1. Okay, so this cycle just keeps repeating every 4 times, or like every 4 like powers of I. But really what I get out of it is, for this question, is these values here are the most relevant. So I to the third power, I just replace that with minus I, and then I write my x squared. And then plus 3 times I squared is -1, and then times x, and then minus ix. And then we have minus 2i, because we're doing +2 times minus I. So you have minus 2i x squared, and then we have minus 3x, and then minus ix. And then from here, what we're going to do is we just scan the answer choices here. So we have minus 2i x squared, minus 3x, and not plus ix. So this one is out. That was almost this one. It looks like choice 3. Question 7, which sequence has a common ratio of 1/2? So a common ratio of 1/2 means that we multiply by 1/2 to get from one term to the next. So if we look at choice 1, if we did -1/4 a, and then we multiply this by 1/2, we would get -1 times 1 is -1, and then 4 times 2 is 8, and the a just tags along. So it looks like so far choice 1 is good. But now I just go ahead and multiply by 1/2 again. So let me just actually show that I'll do this one more time. So I'm going to say here, forward arrow. Now I do -1/8 a times 1/2. And this brings us to -1 times 1 is -1, over 8 times 2 is 16, and the a just tags along. So I usually just do this mental math myself, and then see if I multiply by a half again, I still have the negative, and the denominator doubles again. So choice 1 right away is our answer. The reason why choice 2 is no good, you might be thinking like, wait a minute, the denominators are dividing by 2 each time. It's very tempting to go with choice 2, but the reason why this is no good is if the denominators are cutting in half, that means we're multiplying by a common ratio. We usually say r when we're talking about the common ratio, but in choice 2, the common ratio is 2. You could see if I do this work over here, 1 over 32 and then a times 2 would give us 2 over 32 times a, and this would simplify to 1 over 16a. So choice 2 is out because the common ratio is not 1/2. And then we look at some of the other answer choices here, and these are definitely starting to get a little bit wackier. Another trick you could use when you want to look for a common ratio is you could divide any 2 consecutive terms. You divide one term by the one before it. So if I did 39 over 2a and I divide that by 20a, the a over a's just cancel. I could call this 20 over 1, and then this is 39 over 2 times 1 over 20. So this one looks like the common ratio is 39 over 40, but I would have to see if I multiply by 39 over 40 again to see if that would bring us to the next value over here. So at that point, though, I just see that it's clearly not 1/2. So I'm just like, all right, not this answer choice. Okay, and then same thing with this one. If we did 22.5a divided by 22a, I divide this term by the one before it. Notice a over a cancels, and 22.5 divided by 22 is definitely not 1/2. So this one's out, definitely choice 1. Question 8, the result of dividing 2x to the third plus 6x squared plus 7x plus 2 by x plus 1 is, and we have these 4 answer choices to choose from. So for this one, we could do this a few different ways, but one way would be to do synthetic division. So with synthetic division, what you do is you take the factor x plus 1 that you're dividing by, and you set it equal to 0, and the root would be x equals -1. And then when you're doing synthetic division, you write the root on the outside like this, and you write the coefficients of the polynomial on the inside. So I have 2x to the third plus 6x squared plus 7x and then plus 2. And then I just start the process here. If this were, let's say, a minus 6x squared, then I would put a negative here. And let's say there was like no x term, I would put a 0 in place of the coefficient of x. So I bring down this 2, and then -1 times 2 is -2. And then I add 6 plus -2 is 4. -1 times 4 is -4. 7 plus -4 is 3. And then finally, -1 times 3 is -3. And then 2 minus 3 is -1. This is our remainder. Okay, so we have a remainder of -1. And now the coefficients tell me what my quotient is. Since I'm dividing an x to the third, or a degree 3 polynomial by an x plus 1, these are going to be starting at power 2 here. So I'm going to have 2x squared plus 4x plus 3, and then -1, I write -1 over the original divisor, x plus 1. So now let's see, we scan the answer choices. This is going to match up with choice 1. But just know this Regents is 3 hours long, so you have time to do these questions in the calculator. So when you're dividing polynomials, I would strongly advise you press alpha y equals enter, or alpha x if you could get to the fraction shortcut faster, and actually type this out. So we have 2x to the power 3, and then we have plus 6x to the second power, plus 7x, plus 2, and we're dividing this by x plus 1. And I claim that this is equal to choice 1, so I write in my y2, my answer choice, 2x squared plus 4x plus 3, and then minus alpha y equals enter to pull up the fraction, and the fraction is 1 over x plus 1. Okay, I could press graph here and see the graphs completely overlap. So choice 1's looking good. The calculator is out of like standard form from before, so if I press zoom 6, that puts the calculator back to normal. Okay, and we can see once again the graphs overlap. So choice 1's expression is equivalent to the quotient here. Question 9, the probabilities that a randomly selected teenager uses social media websites F and I are shown below. So here are the probabilities, and then we have, given this information, what is the probability of F and I, the probability that a randomly selected teenager uses both websites. So for questions like this, I'll be honest, I forget the formulas quite often. However, what I like to do for questions like this is draw out a Venn diagram to help me remember the idea of how the probabilities connect into an equation. So when I look at, let's say, the probability of f. So the probability of f, I think of this entire circle. So I would say the probability of f, and then plus the probability of I would be this circle here. And it would go all the way through. So plus the probability of I. And now we have to think about something. When I highlighted circle F here and circle I, notice how this space over here, where they overlap, got highlighted twice. And that is the probability. So this is the probability of F and I. Okay, and we could write it like this, the probability of F and I. So notice this got counted twice. Okay, it got counted the first time I colored in the circle in red and purple. So if I subtract the probability of F and I, that'll make sure that this is only counted once. Okay, and what this encompasses here, all of this together, if we count, the two circles, but we only count the overlap once, this tells us the probability of F or I. Okay, so this is the probability of F or I, which I could write like this. So now I just plug this stuff in. So the probability of F is 0.71 plus the probability of I is 0.52, and then minus the probability of F and I is what we're looking for. And now we could say equals the probability of F or I is 0.77. Okay, so now this is the equation we want to solve. So we could just work this out. We have 0.71 plus 0.52. And we just add this up here, and we're going to get 1.23. So we get 1.23 minus the probability of F and I equals 0.77. So now I just subtract 0.77. So I'll do that on both sides here. Let me just move this over. And this I could just type in a calculator, but I'll just go ahead and do the subtraction right here. So I'm going to borrow, and then 13 minus 7 is 6. And then here it's like I'm doing 11 minus 7 is 4. So I get 0.46 minus the probability of F and I is equal to the right side is 0. And now if I just add this term to the other side, this tells me that the probability of F and I occurring is equal to 0.46, which is choice 3. Question 10, consider f of x equals x minus 2 squared times x plus 3 and g of x as strictly defined in the table below. And then we want to know which statements must be true based on the information given. And if we look at Roman numeral 1 first, we have both f of x and g of x have the same x-intercepts. So just know the x-intercepts are also known as the roots. And when you have roots or x-intercepts, that's when y is equal to 0. So if we look at f of x first, so I'm going to take f of x, and I'm going to set f of x, the x minus 2 squared times x plus 3, equal to 0. And for this, when you have your function in factored form, the roots you could find by just taking the opposite of the inside. So in a case like this, I could just think of x minus 2 equals 0 would be true when x equals 2. And you see how 2 is the opposite of minus 2. So the first function here would have an x-intercept at 2, and it would have another x-intercept when x plus 3 is equal to 0, which would be when x is negative 3. Okay, so the x-intercepts are 2 and negative 3. But if we look at the g of x function, which is strictly defined by the table below, which means all of g of x is just whatever's in this table here. And let's pay attention to when is the y value 0? Well, that's when x is negative 3 and when x is positive 2, which matches the x-intercepts for f of x. So Roman numeral 1 is definitely true, which means this answer choice is out and this answer choice is out. But now we could look next here at the Roman numeral 2. Both f of x and g of x have a y-intercept at y equals negative 6. So for a y-intercept, you would look what happens when x is equal to 0. So for the first function here, f of x, and be mindful here, I could do this in the calculator, but I'll just show this work over here for now. So if I plug in x equals 0 to the function, I get 0 minus 2 in parentheses squared times 0 plus 3. So I'm just replacing these x's here with x equals 0. And this gives us f of 0 equals, and we have negative 2 squared times 3. And then if I do order of operations, negative 2 to the second power is -2 times -2, which is +4, times 3 is equal to 12. But now let's pay attention to what happens when x is 0 for the function g of x. When x is 0, the y value is -6. So for g of x, we have a y-intercept at y equals -6. But for f of x, that's not true. So Roman numeral 2 is out. It's only Roman numeral 1. So choice 1 is our answer. Now, one thing I want to point out, if doing all that algebra by hand is too stressful, we could go to the calculator and type in f of x. So we have parentheses x minus 2, and this is being squared, and then times x plus 3. And if I press graph here, and we look at what's going on here, see how we have an x-intercept at x equals -3 and +2. So if finding the x-intercepts was too stressful, we could, once again, just look at the graph and see where the graph touches the x-axis. For the y-axis, I would have to bump my y maximum up to, let's say, 20, so that I could see when f of x crosses the y-axis. And we could see that this is going up here at 0, 12. If I press second trace and then value here, and I plug in x equals 0, see when x is 0, the y value is 12. So once again, the y-intercepts here are both not equal to -6. F of x, the y-intercept is 12. Question 11, Josie examines the graphs of f of x equals 3 to the x power minus 8 and g of x equals 1 over x squared minus 4. The number of solutions to f of x equals g of x is, and for this one, we're right back to the calculator. So we're just going to type in here 3 to the x power. So 3, we press this little up arrow here, and then x, and then we hit the right arrow to get out of the exponent, and we write minus 8. And then for g of x, I'll write alpha y equals enter to make a blank fraction, and then we have 1 over x squared, and then minus 4. And I press graph, and this could be a little bit tricky to see here. Let me just go back to Zoom 6 standard. And actually here we could see everything that's going on. The number of solutions is equal to the number of points where the red and the blue intersect. And notice that we have a point of intersection here, here, and here. So there's 3. So choice 3 is already looking good. If I had to actually find them, though, I would press second trace number 5. And I just scroll to the neighborhood where the points, or where the graphs intersect. I press enter 3 times, and here would be one solution. If I did second trace 5 and went over to the other part of the graph here, see how this would tell me my second solution. And I could do that again to find my third solution. But they just want to know how many solutions there are, and there are 3. So once again, there are 3 points of intersection between the graphs, so there's 3 solutions. Question 12, which binomial is a factor of g to the third plus 6g squared plus g minus 14? So for this question, we could use the idea that factors and roots have an opposite relationship. So what I mean by that is if g minus 1 is a factor of this polynomial here, then what we could say is this would mean that g equals 1 is a root. And if choice 2 were the answer, that would mean g equals 2 is a root of this polynomial. And then I could say for choice 3, g equals -1 is a root. And then for 4, g equals -2. So now we could just write this in the calculator. So we go back to the y equals here, and I'll just clear out what we had before. And we could just write in, so I'm going to write x to the third instead of g to the third. So we have x to the third, and then plus 6x squared. And then we have plus x, and then minus 14. And we press second graph here and go to the table. And now we look and notice that we have a root at x equals -2. And that would correspond to having a root at g equals -2, which is saying here that g plus 2 is a factor of this original polynomial. So choice 4 is our answer. So once again, having a root at x equals -2 tells us that g plus 2 is the factor, choice 4. But what we could do with this is we could take the polynomial that we started with. So we have g to the third. I'll just write this a little bit lower. So g to the third plus 6g squared plus g minus 14. And we could divide this by the factor g plus 2. And I recommend using the calculator, though, for this question, because if you have to do this and then go through all 4 answer choices to get here, that's going to eat up a lot of time. But what we do now is we divide the leading terms. So I do g to the third divided by g is g squared. And then I multiply g squared times g is g to the third. And then g squared times 2 is 2g squared. And then what you do with polynomial division is you subtract each of these pieces. So the first 2 terms here cancel out, but then 6g squared minus 2g squared is 4g to the second. And then I bring down the next term and just continue the process. So now I'm going to divide the leading terms here. So I'm going to do 4g squared divided by g is 4g. So I get plus 4g, distribute, and I get 4g squared plus 4g times 2 is 8g. Okay, so this one just goes like this. And now subtract. So I subtract these terms. The first two cancel, and g minus 8g is minus 7g. And then I bring down that last term here, the minus 14. Okay, so this one comes down. And then once again, I divide leading terms. So negative 7g divided by g is minus 7. And when I distribute, I get minus 7 times g is minus 7g. And then minus 7 times 2 is minus 14. And this time when I subtract, so I'm going to subtract minus 7g here. So I'm subtracting each of these. Notice that everything cancels out nicely. Negative 7g minus negative 7g cancels out. And minus 14 minus minus 14 cancels out. I get no remainder. So this factor divides the original polynomial evenly. So it's definitely a factor of this polynomial. Question 13, consider the recursively defined sequence below. And we want to know which explicit formula represents the same sequence. So when I look at questions like this, when we have a recursive sequence, I always look at the a sub n minus 1 piece, and I call that the previous term. Okay, so that's how recursive sequences work, is they're built off of the previous terms. So what we have here is, let's say I want to build this up. a1 is equal to 8, and then a sub 2, so if I plug in n equals 2 into the formula a sub n equals, I get a sub 2 is equal to 2 times a sub, and then I plug in 2, and I would get 2 minus 1 is 1. So that would tell me a sub 2 equals 2 times a sub 1. A sub 1 was 8, and I get 2 times 8 is 16. So you see what's happening is I'm just doubling the previous term to get to the next term. Okay, so then a sub 3 I could plug in, or I could just see, oh, it's going to go times 2 each time, and I would get 32. A sub 4 would be times 2, which would give us 64, and so on. So it looks like a power of 2 situation. So choice 2 is out because this is base 4, and this would tell us to multiply by 4 each time. So this formula is not going to be good. This formula is not going to be good as well. So it's going to be one of these answer choices here. So what we could do is we look and say, okay, for a sub 1, that would mean when n equals 1, I should get a sub 1 is equal to 8. But watch what happens when I plug it into the first answer choice. If I plug in there, like let's say I have this formula here. If I plug in n equals 1, that gives me a sub 1 equals 2 to the first, which is 2. And that doesn't match what we should have for our first term. So by process of elimination, we have to go with choice 3, but let's see what happens. So I plug in, let's say n equals 1 to, I have a sub n equals 2 to the n plus 2 power. And for this one, I get a sub 1 equals 2 to the 1 plus 2, which is 2 to the third power, and 2 times 2 times 2 is 8. So right away, like that one matches with the first term. If I want to see what happens if I, let's say, plug in n equals 3, see, that would give me a sub 3, so I'm plugging in n equals 3, equals 2 to the 3 plus 2, which gives me 2 to the 5th power. And 2 to the 5th power, if you punch that into a calculator, is going to give you 32. So the formula for choice 3 is definitely checking out. Question 14, what is the exact value of tangent of negative 5 pi over 6? So I'll show how to do this without a calculator, and then I'll show how to do this with a calculator right after. So notice here the angle is written in radians. So if you want, what you could do is you could convert the angle to degrees. So negative 5 pi over 6, if you want to write this in degree form, you multiply by 180 over pi radians. And then pi over pi cancels. I could do 180 divided by 6 is 30, and then negative 5 times 30 is negative 150. So we have a negative 150 degree angle here. So I just spin like this. Okay, I'm going this way. Let me just make that a little neater. So the angle, I'm starting in standard position, and I'm going this way. I'm not going counterclockwise. I'm going clockwise since the angle is negative. And that would put me in this location here in quadrant 3. Okay, so the angle is going to terminate in quadrant 3 like this. And one thing to be mindful of here is this phrase, ASTC. This tells you where the trig functions are positive or negative. So if we have an angle that terminates in quadrant 3, only tangent and its reciprocal are positive in quadrant 3. Okay, the way to remember this, you could say all students take calculus. I've heard some people say all students take crack, whichever one you could remember, please use as long as you get it right at the Regents. Okay, so we're in quadrant 3. So I know when we're finding the tangent of that angle, that our ratio should come out positive. So these answer choices are out. And now what I could do though is use the concept of reference angles, right? If this angle here, like the absolute value of the angle is 150 degrees, like I know technically we're looking at a negative 150 here because we're spinning this way, but this angle itself measures 150. The reference angle is the positive acute angle between the terminal side of the angle and the x-axis. So see how that missing angle here would be 30 degrees, and that's because we are, once again, on the x-axis here, where a straight line makes 180. 180 minus 150 is going to give us 30. So the positive acute angle here is 30 degrees. So what that allows us to do is say that tangent of negative 5 pi over 6 radians is equal to positive tangent of the reference angle. So this is our reference angle of 30 degrees. Okay, so this is what we need to find. If you have the table memorized for your trig values, then great. I could go through the table here. Where this comes from to teach you like a little bit of concept here is when I have an equilateral triangle like this with a 60-degree angle here, a 60-degree angle here, and at the top, and I drop down a perpendicular bisector, that makes a 90-degree angle here and a 30-degree angle up top. Let's say this equilateral triangle was side length 2 and 2, then this would be 1 and 1 because I'm chopping this side in half. And then I could use Pythagorean theorem to find the altitude here is radical 3. So when I'm finding something like tangent of 30 degrees, tangent, remember the phrase SOHCAHTOA, is opposite over adjacent. So I go opposite of the 30-degree angle is 1 over the side adjacent to 30 is the radical 3. So that's why choice 1 is our answer, 1 over radical 3. Okay, but that was a ton of theory I just threw your way. So just know you could also just go to the calculator. I'll press mode. And notice that we're in radians. And we want to be in radians here because they gave us an angle in radians. And I could just go to the main screen and type tangent of negative 5 pi. I press second and the up arrow and then over 6. And then I press enter. And notice I get a positive decimal here, which as I mentioned before, we should because we have an angle that terminates in quadrant 3. And then I start typing in all the answer choices. 1 divided by square root 3 brings us right to the answer. So automatically 1 is it. It's not choice 2 because see how the decimal came out positive here. And then square root 3, the decimal will not match what we should be getting. So definitely choice 1. Question 15, given m is not equal to 0 and 17 to the 1 over m to the n power equals 17 squared, what is n in terms of m? So for this one, the rule to know is when you have a to the b to the c power, that's equal to a to the b times c. So this equation I could rewrite and say this is 17 to the 1 over m times n. And that's going to be equal to 17 to the second power. And when we multiply a fraction by, a term like this, we could just do n times 1 and then b over m like this. So in the next line, I could say that 17 to the n over m equals 17 squared. But when you have an equation like this where two exponent terms are equal with the same bases, you could just set the powers equal to each other. So I'll do that over here. We could say n over m is equal to 2. So if you want to know what n is in terms of m, we just multiply both sides by m. And this is going to give us n equals 2 times m, giving us choice 1. Question 16, in order to qualify for a college tennis scholarship, Joe needs to win 90% of the matches he plays during his senior year of high school. If he has won 8 out of the 10 matches that he has played, which equation can be used to determine how many more consecutive matches X Joe must win in order for his winning percentage to equal 90%? So for this one, it may be tricky to go right to the answer from reading this, but what I recommend you do for a question like this to help you think is start off with the initial condition. So right now, Joe has won 8 of the 10 matches he has played. So he's 8 for 10. And the scenario here is that Joe has to just keep winning. Okay, he has to keep winning consecutive matches in order to, the goal here is for him to hit a 90% win percentage. But they're saying like, all right, from 8 out of 10, now he just keeps winning. And how many does he have to win in a row to make a 90% win percentage? Because right now, 8 over 10 is the same thing as 80 out of 100, and that's equal to 80%. So he wants to raise his win percentage to 90%. So this will help you gain some insight. You think, all right, let's say he plays another game and wins. So this is the number of wins, and this is total games. So let's say Joe wins the next game. Then he's going to be 9. So I'll just change colors here. But Joe's going to be, let's write this next. He's going to be 9 wins out of 11 games. Okay, because once again, he played 10 games, he won 8. So if he wins the next game, that's 9 wins out of 11 total games. And then we just continue this trend here. So then he would have 10 games won for 12 matches total, 11 for 13, and so on. So what we should notice here is that any one of these, like let's say this one, I could express as 8 plus 1 over 10 plus 1. See, like the next game that Joe plays, he wins that one extra game. And then in this scenario, it would be starting from 8 over 10. It would be the next 2 games he plays, he wins both of them. So that's 8 plus 2 wins over 10 plus 2 games total. Because this is like, once again, the over here, these are the starting amounts. Okay, so this is what the starting amounts are. And then everything is going from there. And then if we look at the next one, Joe started at 8 wins, but that would be if he wins 3 games out of the next 3 matches, which would bump his win total up by 3, and the number of games he played, it would bump that up by 3. So the trend here is that the numerator and denominator is getting the same number added to it. So 8 plus x over 10 plus x is what we're looking for. And out of all of these, the only one that this is matching right now is choice 4. And then we set this equal to 0.90 because this represents 90 out of 100, or 90 hundredths, which is equal to 90%. Okay, so definitely choice 4. Question 17, consider the system of equations below, and we want to know what is the value of x. So for these type of questions here, the thing we want to do is just start eliminating variables. So I look for any matching opposites. So let's say I look at the x's first. We have 3x and a 2x. And then for the y's, we have 2y, 2y, and those are the only y terms. And then we also have here z and minus 2z. So it looks like this one here has a lot of potential to it. And also I could say the second and third equations here have a lot of potential. So there's a lot of ways we could go here in terms of eliminating variables. So maybe the best way to do this for anyone is to just jump in and just think, okay, which terms would be the easiest for me to eliminate here? So maybe I target the second and third equations here. So I'm going to target, I'll call this equation 1, equation 2, and equation 3. So I'm going to target these two. And I say, all right, if I multiply the second equation by 2, so I'm going to do 2 times the second equation, that's going to give us, we'll have 2 times 2y is 4y. And then I multiply the second term by 2, that gives me 2z. And then equals 2 times the constant after is 4. Okay, so I'm just multiplying everything in that second equation by 2. And then equation 3, I'll just rewrite this. So we have 2x minus 2z equals negative 6. And the reason why I multiply by 2 is now we could see here that the z terms have matching opposite coefficients. So now we could just add this stuff together and these terms cancel. And we're going to get 4y. So I'm going to just write that a little neater. We have 4y plus 2x. So I'm just adding these equations together. So I get 4y plus 2x equals 4 plus negative 6 is going to give us negative 2. So this gives me another equation. And now what I could do is I can combine it with this equation up here. But the problem is if I just write these equations next to each other, do you see how the coefficient of x here is 3x and the coefficient over here is 2x, and then the y coefficient is 2y, but this one's 4y. So I need to be able to manipulate this stuff so that the terms here, once again, make matching opposites. And it's better for me to eliminate the y since we want to know what's the value of x. So I'll rewrite this here and I'll switch the order. I'll say 2x plus 4y equals negative 2. But then what I'm going to do is I want to eliminate the y's. And right now I have a 4y and a 2y. I'm going to multiply equation 1 by negative 2. Okay, so I'll just make that a little neater. So negative 2 times equation 1. And if I do negative 2 times 3x, I get negative 6x. Negative 2 times 2y is minus 4y. And then negative 2 times 1 is negative 2. and I could add these equations together. So I do this, 4y minus 4y cancels. 2x plus negative 6x is negative 4x. And then I get negative 2 plus negative 2. So we're adding these as well as negative 4. And then divide both sides by negative 4. And this tells us that x is equal to 1. Okay, so x equals 1 is going to be our solution. If this setting is available on your calculator, what I'm about to show you, I think is very much worth trying out. You could try pressing apps, and then you go to the polynomial simultaneous number 9 here. And we're going to solve the simultaneous equation solver. That's number 2. So I'm going to go to that one here and press enter. And we have 3 equations, and we have 3 unknown variables. Okay, we have an x, a y, and a z. And now I just press graph to go next. And I just write this in. We have a 3x and then plus 2y. There is no z term on the first equation, so I'll just leave it as 0z. And this all equals 1. And then in the second line, I have no x term, so I just press enter. And then plus 2y. And then we have a z term, so I'm just going to put a 1z like this. And that equals 2. Press enter. And then I have 2x. No y term here. And then I have minus 2z. So I could press subtraction here and then enter and then put my 2 like this. And then negative 6 is the value at the end. And now I press graph to solve this. And see how I get x equals 1, y equals negative 1, and z is equal to 4. That's probably why all these other values are showing up here. Let's say a student accidentally solves for the wrong value and they forget to put x down. But here we should be getting choice 1. Question 18, the point 2, negative 3 lies on the graph of the equation y equals f of x. Which point must lie on the graph of the equation y equals f of x minus 4 plus 1? So for this one, it helps to know how to go from this form here of, the point 2, negative 3 to the function form y equals f of x. So when 2, negative 3 is on the graph of your function, you could say f of 2 equals negative 3. Okay, so it helps to be able to go from this form to this form. And then what we could do with this information is now look at what we have next. And for this one, if you know how to shift a function horizontally and vertically, then you could probably do this without even writing this out. So here, if you're able to look at this and say, okay, switching x with x minus 4 sends the graph to the right 4 units. So we're going to the right 4, and then we're going up 1. So if I just sketch this out here, so we have, let's say over here, and of course there's graph paper in the back, but this is okay enough that I could just kind of follow this either mentally or just sketching this out like this. But the point 2, negative 3 would be over here. And if I go to the right 4 units, see how I'm at x equals 2, that would send me 1, 2, 3, 4. So that would send me to 3, 4, 5, 6 in this direction. Okay, so I go 1, 2, 3, 4, and now I'm over here. And then I go up 1 unit. So if right now my y value is at negative 3 and I go up 1, that's going to put me at a y value of negative 2. So this would send us to the point 6, negative 2. And I can see right away choice 4 is it. But let's say you wanted to think of this in terms of the function notation, f of 2 equals negative 3. Then what you could do is you could just scan through the answer choices, plugging in the x values here. So I'm looking at the x values. We have 1, negative 2, 3, and 6. And you plug them in for x over here and see what's going to happen. So let's say I plugged in something like choice 1. So I plug in x equals 1. I would get y equals f of 1 minus 4 and then plus 1. But the problem with this is I have no idea what f of negative 3 is. They told us what f of 2 is, but they didn't tell us what f of negative 3 is. So this one here is not going to give us anything good. But by the time I get to choice 4, notice here when I plug in x equals 6, I get y equals f of 6 minus 4 and then plus 1. And that gives me y equals f of 6 minus 4 is 2. And I write my plus 1, and f of 2 is negative 3. And then negative 3 plus 1 gives us the negative 2 that we need. So choice 4 is definitely it. Question 19, which statement best describes the end behavior of the function y equals log of x minus 3? So for this one, we could start by using the calculator. So I'm going to go over to the y equals. So let me just press second mode to quit that previous screen. And I go to y equals and I type in log of x minus 3. If my log had a different base, remember I could go to math, press up, and then log base is this option here. And it gives me a log where I can make a custom base. But here it's just the standard log. And when there's no number written there, the invisible base is 10. So I press graph here and it gives me this picture. Now, before we move on, I just want to point out that from years of grading the Algebra 2 Regents, I noticed that when it comes to graphing log functions, students really struggle. And I think one of the things that's wrong is that the graphs here get cut off when you're using the TI. So the concept behind logs is that the inside part needs to be positive. Okay, so this piece on the inside needs to be positive, which tells us that x minus 3 has to be greater than 0, which tells us if we solve this, that x has to be greater than 3. So notice that what we have here, what the calculator should be doing, is showing that we have a vertical asymptote at x equals positive 3. Okay, the domain of our function here, so the domain is all x values greater than 3. All right, I'll just make that a little bit neater. So domain is all values x greater than 3. So a better picture of this graph here, so I'll just go ahead and draw this off to the side here, would be we have a vertical asymptote once again at 3. And then for our function, it's going to look something like this. Okay, it's going to go up like that. All right, and the point 40 is on the graph. And this is a much better sketch than what the calculator could produce. But now if we look at the end behavior, as x goes to negative infinity is just not possible because the domain is all x greater than 3. So we can't go all the way to the left. We have to stop at x equals positive 3 here. So now it has to be like, once again, 1 and 3 are out because we can't send x to minus infinity. However, as x approaches 3, the y value is going down to negative infinity. So that one is true. So right away, this one's out and it's going to be choice 2. As x approaches 3, as we're going this way, see how the graph is just dropping down like this? The y value is going to minus infinity. And as x goes all the way to the right, the y values are going up. So y is going to infinity. The only thing that's like a little bit sloppy about this is technically we are approaching 3 from the right side. I want to just point out that we're approaching 3 from the right side. And that's a detail that matters for those of you that move on to calculus. The direction you approach from matters, but for the Algebra 2 Regents, they're just saying, hey, as we approach 3, so we're just assuming here that we're following on the side of 3 where the graph actually exists. The y value is going down to minus infinity, so definitely choice 2. Question 20, the black bear population for a certain area of the Adirondacks can be modeled by the equation b equals, and we have this exponential part here where t is measured in years since 2010. Kieran would like to rewrite this model in terms of a 5-year growth rate, and Kieran's model is best represented by, and we have these 4 options to choose from. So for this one, the concept behind this question is if we look at the original function b, so b of t here, I'll just call it b of t, even though it just says b equals. But for this original function here, this is an exponential growth function here. So we're starting at 5,835, and then we have a positive a growth rate here. The population is growing, so this would be exponential growth. The curve, I'm just doing a rough sketch, would look something like this, something exponential. And what's going on in the beginning is just imagine we're counting by ones. So we're going like this, and we're tracking the growth, let's say 1 year at a time as it goes up. But what Kieran wants to do is, let's say we start at 0, is jump 5 years at a time. And notice that if we're jumping 5 years at a time, the growth rate is going to be higher here, okay? I mean, it's still going to give us the same values that we have along this curve. We see how we're taking bigger jumps if we're going by 5 years, which would mean that the base here of our exponent is going to be greater. So you see how this one here for choices 1 and 2, the base is smaller. So 1 and 2 are out, and now this narrows it down to choices 3 and choice 4. But remember here, they told us t is measured in years since 2010. So if we're jumping 5 years at a time, that means when we plug in t equals 5, let's say to the first equation, that we're going to get over here, 5 divided by 5 is 1, and we apply this new base 1 time because we're just jumping 5 years at a time. But watch what happens if we plugged in t equals 5 to the fourth answer choice. We would get 5 times 5 is 25, and they would apply this base 25 times. We'd multiply the original bear population by this base 25 times, which would just really like make the population, like this is just not counting it properly, okay? So choice 4 is out. So just by like thinking through this logically, this has to be choice 3, but I'll show how to get this definitively as well. So if you just want to see the algebra behind this, we have a to the b to the c power is a to the b times c. And what we're doing is we're starting with this equation here, the b equals 5,835.943, and we're taking this base here, the 1.026, and this is being raised to the t power, But what we're doing is first we're going to raise this to the 5th power, and then I'll move this over here. So I'm just move this away from the graph. After we raise it to the 5th power, we're raising it to the t over 5 power. Okay, and the concept is using this algebra formula or property of exponent here. When I multiply 5 times t over 5, do you see how 5 over 5 cancels? And it would bring us right back to t. So what we're getting here is equivalent to the original thing. It's just in different form. And now when we raise this base here to the 5th power, this we would just have to plug into the calculator. So we go back to the main screen here, and we're going to have 1.026, and we're raising this to the 5th power. So now we can write this out. This would give us b equals 5,835.943. And now the base here, this entire expression here to the 5th power, we could replace with the value we found in the calculator and see how we get 1.13, and then we get 6938 if we stop here to the t over 5 power. Okay, so once again, notice how we're getting this base here to the t over 5, which is matching choice 3. And the 5t power here just wouldn't make sense. For the 5t power, that would be if we raise the original base to the 1/5, and then we could express it to the 5t, which choice 2 here would be if we had applied it correctly, but the other way. Okay, but that's not what's happening here. We're going with choice 3. Question 21, which expression or expressions are equal to 0 for all real numbers x? So we have these 3 Roman numerals to choose from. And for questions like this, we could either just work out the algebra ourselves, or we could plug in values for x and y and see that these random values of x and y make 0. So let's say Roman numeral 1. When I look at this, what jumps out at me first is that the first 2 terms here are like terms. So the same way you would say x plus x equals 2x, we could say for this one here, so I'm just going to do a forward arrow and simplify this, that when I have 1x squared plus y squared squared plus another 1x squared plus y squared squared, that's going to give 2x squared plus y squared squared. Okay, so the stuff that I highlighted combines nicely to this. And then I could just say minus the 2x squared plus y squared squared. So this first Roman numeral will always equal 0 because I'm subtracting equal things once I start simplifying this. Okay, and it needs to be true once again for all real numbers x and y. So Roman numeral 1 is good, which means choice 2 is out. Now I look at the next one here and I see that these 2 expressions that we're subtracting. So you see how we're subtracting x squared plus y squared squared, but we're also on the second expression here having x squared minus y squared squared. So we are subtracting unequal things. This needs to be true for all real numbers x and y. So yes, this might be true when x is 0 and y is 0. So I could say, wait, what about when x is 0, y is 0? But this needs to be true all the time, no matter what x and y are. So these, like right away, I say the difference is not 0 for all x, y, okay, for all real numbers x, y, because I'm subtracting unequal things. Okay, see how we got x squared plus y squared squared and x squared minus y squared squared. Okay, so we're not subtracting equal things. So Roman numeral 2 is not always true, which means that we are down to choice 1 and choice 4. So next, we look, and Roman numeral 3 is pretty involved. So what you could do for this is, once again, you could plug in, let's say, something like x equals 1 and y equals, I would plug in something like x equals 1 and y is equal to 3. Something sort of random here. And if I plug this in, you see how I get parentheses 1 squared is 1 plus, so I'll just write this over here. Let's move this over. If x is 1 and y is 3, then I could say x squared is 1 times 1 and y squared is equal to 9. So I would get in the last part here, x squared plus y squared is 1 plus 9 to the 2nd power minus, and then I have x squared is 1 minus y squared is 9 being squared minus, and then in parentheses, I have 2 times x times y. So if I do 2 times 1, I get 2, and then times 3 gives me 6. And then this is being squared, and let's see. 1 plus 9 is 10. 10 squared is 100 minus, this gives me negative 8 squared is 64. And be mindful, it's negative 8 on the inside like this, being squared, and I have a subtraction sign outside. So I'm subtracting positive 64, because negative 8 times negative 8 is positive 64, but the minus is outside, so the minus just tags along like this. And then this would give me minus 6 to the second power is 36. And this difference is definitely working out to 0. So Roman numeral 3 is also looking good. Now, if you really want to be convinced and do this algebraically, then what you could do for the third one here is actually expand, let's say x squared plus y squared squared. I would have to multiply this out. Okay, don't just say x to the fourth plus y to the fourth. That's a common mistake. You would have x squared times x squared is x to the 4, but then you would have plus x squared y squared when you multiply, the last first and last term together like this. And then when you multiply these two terms, you get another plus x squared y squared, and then plus y to the 4th at the end like this. Okay, so this, let me just move this stuff over here. So I'll try to scoop this up without getting all the other stuff here. So, I just got to now move the square like this and move the equals with it like this. But when I combine this stuff, I have now x to the 4th plus 2x squared y squared plus y to the 4th. Okay, so if I were simplifying this, the long way, this part here, once again, would be x to the 4th plus 2x squared y squared and then plus y to the 4th. But then I would be subtracting, when I do x squared minus y squared squared, I'm subtracting x to the 4th, but instead of having a plus 2x squared y squared, I have a minus 2x squared y squared and then plus y to the 4th. Okay, if I were to expand that. And then this is minus, and now I just square each piece. 2 squared is 4. X squared is x squared. And then y squared is y squared. And if I work this out, so I'll write this over here. We have x to the 4th plus 2x squared y squared plus y to the 4th, and then minus x to the 4th. So the minus distributes like this. And then I get plus 2x squared y squared, and then minus y to the 4th, minus 4x squared y squared. And then here, x to the 4th minus x to the 4th cancels. Y to the 4th minus y to the 4th cancels. And then here, what I have is 2x squared y squared plus 2x squared y squared minus 4x squared y squared. But these two here, I could combine to make 4x squared y squared and then minus 4x squared y squared at the end. And then these are equal, being subtracted here. So we have subtracting equal terms gives us 0. So if we do this algebraically, that's the strongest argument. But yeah, if that algebra is a little scary, then you just plug in, don't plug in like x equals 1, y equals 1. Plug in like not the most like typical numbers here, like 1 and 3 should do the trick. But choice 4 is our answer. Question 22, the equation here has, and we want to see what type of solutions this equation has. Does it have rational, irrational, imaginary, or no solutions? So first I'll do this algebraically. So we're starting off with this equation. And when I want to deal with an equation like this, what I want to do is I want to get rid of all of the denominators. But first I'm just going to point out that we have a denominator here with an x. So I want to say right away that x cannot be equal to 0. Because if x were equal to 0, we would have division by 0. And that would make this whole equation here undefined. So I just like to look for those values of x right away. But then the next thing I think about is the least common denominator. Okay, so what is the least common denominator when we are dealing with a denominator of x and 5? So in this case here, the least common denominator would be 5x. And then that's what I'm going to multiply all of the terms by. And then let's see what happens. When we multiply this all the way across, we're going to have 5x over x minus, and then we have 5x times 1/5. So we do 5x times the 1 on top is 5x over 5, and then equals 5x times x on top is 5x squared, and we're dividing that last term by 5. And now we just start canceling stuff. So we have x over x cancels out, giving us 5, minus 5 over 5 cancels, giving us x, equals 5 over 5 cancels here, giving us x squared. So we get this equation, but when you have a quadratic equation, you want to move everything to one side so that you have 0 on the other side. Okay, so I'm going to add x to both sides and subtract 5 on both sides. And then here, these terms cancel, and we have 0 equals x squared plus x minus 5. And now from this step, the thing to know is the quadratic formula. Okay, so I'm just going to write down the quadratic formula. And when we have this formula here, and we want to determine the nature of the roots, if that is, we want to determine if they're rational, irrational, or imaginary, the key component here is the discriminant. That's the term here under the square root. So in this quadratic here, we have an a value of 1, we have a b value of 1, and we have a c value of -5. So I just want to find what is b squared minus 4ac. So that's 1 squared minus 4 times 1 times -5. See, I'm just plugging in. So we have b squared minus 4 times 1 times -5. And this tells us what we need to know for this question. So 1 squared gives us 1, and then we have minus minus goes plus, and this gives us 21. So the fact that we got 21, I want to point out that this is positive and not a perfect square. Okay, so not a perfect square. And what that tells us is that our roots here are irrational. Okay, we're going to have an irrational solution to this quadratic equation. In the event, like let's say, we'll just look at the other cases here. Let's say we had b squared minus 4ac equals 0. Then in this case here, we would have rational solutions, but they would be equal. Okay, so like equal and rational, but that didn't show up as an answer choice. If b squared minus 4ac, like let's say this were b squared minus 4ac is a perfect square, in this case, you would have rational roots. Okay, so this would be rational. And then the last case to explore here would be if, I'll write it over here, b squared minus 4ac, just make that neater, b squared minus 4ac less than 0, then our roots would be imaginary. Okay, so I just want to point this out for this question here, that since we're dealing with a case here where we have something positive but not a perfect square, then we have irrational roots. Okay, so in this case here, once again, when the discriminant is non-perfect square positive, you have irrational solutions. Question 23, for x not equal to plus or minus 4y, the expression here is equivalent to, and we have these 4 answer choices to choose from. So for this one, what I like to imagine when I'm factoring something like this, what we have on top with x's and y's, is I pretend that there's no y involved. So imagine instead I had x squared plus 3x and then minus 28. So I just get rid of the y terms. This would factor nicely to x plus 7 times x minus 4. And I could check this. 7 plus -4 is 3, and 7 times -4 is -28. So the only difference between this one here and this one here is that we have the y and the y squared. So when I factor this, I'm really thinking of how I factor this thing above. So now I'm going to say this is equivalent to, instead of x plus 7, I'm going to have x plus 7y, and then times x not minus 4, I'm going to write x minus 4y. And then I do a little mental math here just to check this out. So x times x is x squared, and then I get a 7xy minus 4xy, which gives us 3xy, and then 7y times minus 4y gives us minus 28y squared. So this is looking good. And then for this piece over here, what I'm thinking of is a squared minus b squared equals a plus b times a minus b. So the difference of 2 squares, that's how we're going to deal with this. So I say, all right, well, I have 4y times 4y makes 16y squared. So I'm going to have 4y, and then I write my plus or minus, and then I just think x times x makes x squared, and then that's how I factor that piece. But here, what makes this question a little bit tricky is this part. The most common mistake I see is students look at those and go, oh, I'll just cancel these. All right, but for this, we just have to be careful. When you have factors like this, as long as a is not equal to b, a minus b over b minus a equals -1. Okay, so if you just see that and you just want to cancel this and then put a -1 somewhere, that's fine. But if that doesn't make sense, you're like, wait, I don't see it, then what you could do is you can factor out the -1 and then just simplify. So this one over here, I'll just rewrite this. We have x plus 7y, and then I'm going to take out a -1 on top, and then when I take the -1 out, I'm going to have not a minus 4y, I'm going to have a plus 4y, and then a minus x. And you can see if I were to distribute this, it would bring me right back to the factor above. Okay, and now I have 4y plus x. So I'll just make that a little neater, 4y plus x. And the second factor is 4y minus x. And now they just cancel out nicely like this. And then I start looking through the answer choices, and I'm like, okay, so it's not looking like this one, because this factors nicely. The x plus 4y on bottom doesn't match this. So now it's like one of these. But then I look and you see how this is the answer where the students don't put out that extra factor of -1. So this one's out, it's going to be this. And if we want to see like, wait, how is this matching up? The -1 I distributed here, and then I would have minus x and then minus 7y on top over the 4y plus x, or I could just switch the order here to x plus 4y. So this here would match up with choice 4. Question 24, which equation represents a parabola with a focus of -2, 1 and a directrix of y equals 5? So for this one, what I like to think about is the concept of what a parabola is. So when I have a parabola, the focus is the point over here, and the directrix is a line underneath if I draw my parabola like this. And the concept of what a parabola is that it is the set of all points that are the same distance away from this line that we call the directrix and this point that we call the focus. Okay, so for any point here on that curve, x, y, wherever that is in space, I'll just make this a little bit neater. That point is going to be the same distance away from this point and this directrix here. And if my parabola were to open the other way like this, then my focus would be on the inside like that, and the directrix would be above. Okay, but remember, it's the same distance away, so I would have to just space this as nicely as possible. And that's what I think about going into these questions. So when they tell me the details here, so I just draw out an xy axis. We have a focus at -2, 1, and we have a directrix at y equals 5. So it looks like most of what's happening here is happening in this quadrant here, in quadrant 2. So y equals 5, so at 1, 2, 3, 4, and I'll just extend this a bit, 5 up here. Okay, so this would be where our directrix is. And since it's the kind where the directrix is above the focus, so see how this over here is our focus, and this is our directrix. This is going to be one of those parabolas where the parabola opens downwards like this. Okay, so that's just where my head goes right away. So this is at a y value of 1. So I'll just label these points here. So we have a y value of 1, 2, 3, 4, 5. And then the next idea is I look for the vertex. The vertex is always exactly in the middle of the focus and the directrix. So I just line up the 3 points like this, and the vertex is in the middle of those. So you see if our directrix is here, we're at -2, 1, and then this point here, -2, 5. So in the middle of that would be -2, 3. And if I had to, I could just do this math in my head. See how we're going up from y equals 1 to y equals 5. I just take the average of 5 and 1, and that's going to give us 3. Okay, so this is where our vertex is. And then I don't necessarily draw this to scale, but it's just going to open downward like this, our parabola. Okay, so when I have a parabola like this, that means that I need to have a negative coefficient. So when you have y equals ax squared plus bx plus c, in this case, since we're opening downwards here, our a value is going to be less than 0. And then I look at the answer choices and I eliminate these two, because if I were to divide by 5 or divide by 8, I would have a positive in front of my x squared. So I know right away it's not one of these. And then the next thing I think about is vertex form. So I have y equals a times x minus h squared, and then plus k. And in this case, our vertex is at the point -2, 3. Okay, so our vertex for this parabola is at -2, 3. So when I plug into the formula, I have y equals a times, and our h value and our k value represent the coordinates of our vertex. So I'd have x minus -2 becomes x plus 2 squared. And then plus k is equal to 3. So when I start to work with this here, I look at the remaining answer choices, and I see right away that it's going to have to be this one. And the reason being behind this is that if I solve this to represent or to go in the form of the other remaining answer choices here, or all the answer choices, I could start by subtracting 3 on both sides. And then I would have, I'll write this in parentheses here, I would have y minus 3 equals a times x plus 2 squared. So you see, like, my factors would be y minus 3 and x plus 2, not y minus 1. Now you might be thinking, all right, well, where are they getting this value from here and this value from here. Well, for this is where the formula gets a little bit, tricky. What we do with these focused directrix questions is we actually write y equals 1 over 4p times x minus h squared plus k. And the p value is the distance from the vertex to the directrix or from the vertex to the focus. So you see how these are 2 away from each other? So these are 2 away. I'll just make that curly bracket a little bit nicer. So these are 2 away. So our p value here is equal to 2. All right, so that's the idea. But the other thing I have to account for is the fact, once again, that this is opening downward. So I'm going to put a negative in front when I do this. Okay, so over here, I'll just write out this last part. So we're just going to look that for the last piece here, I would say, okay, so y minus 3 equals, my a value is negative since this is opening downward, and I have 1 over 4p. So I'm going to have 1 over 4 times 2 makes 1 over 8. Okay, so this is going to make negative 1 over 8 times x plus 2 squared. And then if I want to solve for x plus 2 squared, I just multiply both sides by negative 8. Okay, so negative 8 here and negative 8 here. And then these terms cancel out. And I'll write the right side first. We have x plus 2 squared equals negative 8 times y minus 3. Okay, and then that's how we get our exact match. But once again, if you just think about vertex form and you know the concept of what a focus and a directrix is, then you could go through questions like this very nicely. So now we're moving on to the part 2 questions. There's 8 questions here and each one is worth 2 credits. Question 25, data collected showing the depth of water in a bay during a 24-hour period are shown in the graph below. The depth of water can be modeled with a trigonometric function of the form d of t equals a times sine pi over 6t plus c. And we have to estimate the value of a to the nearest integer. Justify your answer. So for this one, what I'm thinking of is a sine curve. It looks like this. So I could see the outline of the sine curve here. And we just have to know what each piece means. So here, this dotted line I'm drawing right now is the midline. So this is the midline. And when you have a formula like this, the constant that we're adding at the end represents the midline. Okay, so in this case, if we had to solve for each piece, our values c here, so it looks like they're counting by 5s. We have 5, 10, and then we have 15, 20, 25. The midline looks like it's sitting at around 15. And remember, they're saying estimate to the nearest integer, which is a whole number. So here, our midline, our c value is going to be equal to 15. Now, our a value represents the amplitude. Okay, so this here is the amplitude. And if we look at the graph, the amplitude, or we'll just think in general first, the amplitude is the distance from the midline up to the maximum. Or I could say the distance from the midline down to the minimum. Okay, so here, see, this is our maximum value. And in this graph here, it looks like our maximum is reaching at around 25. So what is our amplitude? So that's this space here. This would represent our amplitude. We could just take the maximum value minus the midline. Okay, so what is our a value to the nearest integer? We're going to say a equals 25 minus 15. So we could say a is roughly equal to 10. Okay, just know this also works if we had gone from the midline down to the minimum. So if instead we look at the minimum value here, 5, and done 15 minus 5, we also get 10. Just one thing to be careful of, a lot of students, when they forget what the amplitude is, they do the maximum minus the minimum. Okay, that's a very common wrong answer. They'll do 25 minus 5 is 20, which will double the amplitude. But the amplitude, once again, is going specifically from the midline to the max or from the midline to the minimum. It's that distance. So that's what we're writing here. Question 26, algebraically determine the solution to the equation below. So for this 2-point question, we have quite a bit of algebra to do. So first what we want to do is we want to get that square root term by itself. So we could start this here by subtracting x on both sides. And what we're going to have is we have x minus x canceling, and now we have square root of x minus 2 is equal to, and on the right side we have 4 minus x. And the reason we do this is now we're able to square both sides and get rid of that square root. Okay, so I'm going to square the left side, and I'm going to square the right side. So when we do radical x minus 2 times itself, we're just going to get x minus 2. equals, and here we just have to be careful. We have to make sure that when we do this, that we're actually expanding and doing 4 minus x times 4 minus x. Okay, so this one here, we would have 4 times 4 is 16. Then we have 4 times negative x is minus 4x. And then negative x times 4 is minus 4x. And then negative x times negative x is plus x squared. Just be careful that you don't just do the first term squared and then plus the second term squared. That's a very common mistake to make with these questions. And now from here, we're just going to go ahead and close this out. So we have x minus 2 equals, and then we have 16 minus 8x plus x squared. And now we want this quadratic with everything on one side and 0 on the other. So we're going to go minus x on both sides, and we could also go plus 2 on both sides. So the left side cancels out completely, and I'm just going to write this result over here. So we're going to have 0 equals, and now I'm going to write this in standard form. So we have an x squared, and then we have negative 8x minus x is minus 9x, and then 16 plus 2 is going to give us 18. So we get plus 18. And now we could factor this. So we're going to have two numbers that have a sum of negative 9 and a product of 18 are negative 6 and negative 3. So we could say next that 0 equals x minus 3 times x minus 6. And now this is going to give us two potential roots. So here, the first root we're going to get is x equals 3, and the second one we're going to get is x equals 6. However, we have to think back to the original equation, and the original equation was square root of x minus 2 equals, I'm sorry, let me just write it like this. Square root of x minus 2 plus x equals 4. So for this one, what we want to do is just plug in and check to make sure they work. So we're going to check over here, and I'll plug in x equals 3 first. So if we plug in x equals 3, we get square root of 3 minus 2 plus 3 equals 4. And this one checks out. The square root of 1 is 1, and 1 plus 3 equals 4. Checks out. So we have definitely one solution so far. And then we plug in x equals 6. So when x is equal to 6, we get square root of 6 minus 2 plus 6 is equal to 4. And this one, here's the problem. Square root of 6 minus 2 gives us square root of 4 plus 6 equals 4. And this one is not true. Okay, 2 plus 6 equals 4 is not true. So we have to reject, okay, we're going to have to reject this solution here and just go with 1. All right, that's a lot of work for a 2-point question, but it's something that we need to do here. Question 27, factor the expression completely. And we have x minus 1 squared plus 5 times x minus 1 minus 6. Now, for this one, what you could do is you could make a substitution. If your factoring is super high level, you then could probably just factor this as is. But for these kind of questions, I always recommend writing this in a nicer form. And what I mean by that, it would be nicer if this said something like u squared plus 5u minus 6. Because then we could say, all right, two numbers that have a sum of 5 and a product of negative 6. Okay, so I'm going to say here, let u equal x minus 1. And if u is equal to x minus 1, then we have u squared plus 5u minus 6. Okay, so we make the substitution, and now we could factor this. What two numbers add up to 5 and multiply to negative 6? Well, that would be positive 6 and negative 1. 6 plus negative 1 is 5, and the product of 6 and negative 1 is negative 6. So now when we get here, though, we have to write this back in terms of x at the end. So now we're going to go ahead and substitute one more time. Okay, so you see, like this part here, the x minus 1s we replaced. But now the u terms, at the end, we're going to plug back in x minus 1. So now we get x minus 1 plus 6 times x minus 1 minus 1. Okay, once again, the part that I'm substituting, I'm replacing the u terms with x minus 1. And then just writing the trailing number at the end like this. Okay, see the trailing numbers are just going here. And now to close this out, we just simplify. We have x negative 1 plus 6 is positive 5. And then x minus 1 is going to give us x minus 2. Okay, so this is the factored form that we need. Question 28, the results of a survey of the students at the local high school regarding the topic, what I do to relax, are displayed in the table below. If a student from this survey is selected at random, determine the exact probability that the person claims to relax by listening to music, given that the person is female. So for these questions, sometimes I have to reread them, more than once. Okay, so I read that last part again. Determine the exact probability that the person claims to relax by listening to music given that the person is female. So this part here, the given that the person is female, tells us that we have conditional probability here, that we're only going to be looking at the category here of students that are females. Okay, so we're going to be focusing on just this and ignoring the other part here. Okay, so we're just going to be focusing on this row. And now I read this one more time. So we want to know the exact probability that the person claims to relax by listening to music. Okay, so claims to relax by listening to music. That's going to be this part here. However, once again, we are restricted to this row. So what we want to do here is we want to find what is the total number of females. Okay, so for this, I'm just going to add up 87 plus 94 plus 21. All right, and this we could do in a calculator, but I'll just show this math off to the side here. So we're going to add these values up. 7 plus 4 is 11, plus 1 is 12, carry the 1. And then I have 9 plus 1 is 10, plus 8 is 18, and then plus another 2 is 20. So there's 202 females total. So when we're finding the exact probability, what we're going to do is we're going to say how many females listen to music. That's 94. Out of the total number of females here is 202. Okay, so this would be the exact probability. Now you could type this in a calculator and reduce the fraction, or just reduce it yourself, but you do not have to simplify the fraction. We can just leave it like this. But the concept is part over whole. Okay, so 94 represents the part, and the whole or total number of females is 202. The graph of y equals f of x is shown below. The cubic function has a leading coefficient of 1. Write an equation for f of x. So for this one, there's a few things we have to consider. For one, they told us that we have a cubic function here with a leading coefficient of 1. So my thought process right away for something like this is that this equation, whatever it is going to start off as f of x equals x to the third power, and then plus some other stuff after this. Okay, so we have a cubic function, which means the highest power is 3, and the leading coefficient is 1, which means we need a 1x to the third to start this thing. Now, the other idea is that factors and roots have an opposite relationship. So here I look at this graph and I see that we have a root at -1, -2, -3. Okay, so at x equals -3, we have a root, and we also have a root at x equals 1. Okay, so there's two roots. However, the roots are a little bit different. Notice that the graph here of f of x goes through x equals -3, whereas at x equals 1, the graph is tangent to the x-axis. Okay, so you see how the graph is tangent to the x-axis, which means it touches the x-axis at this one location in this little neighborhood, but doesn't go through it. It just goes back up again. Okay, so we have, at this root, we are tangent to the x-axis. So now we just piece all of that together. Well, if we have a root of x equals -3, this means right before it, we had a factor of x plus 3. Okay, remember, factors and roots have an opposite relationship. And then we have a root at x equals 1. So right above that, we have x minus 1. But here's the catch. When you have a root on a function and the function at this location is tangent to the x-axis, that means we're going to have an even power above the factor. Okay, so I can't just say x minus 1. I could go with x minus 1 squared. All right, and I know I'm going to go with x minus 1 squared because they said we have a cubic function. So if we were to expand this, so this is all part of the thought process, we'd have x plus 3 times x minus 1 squared is going to start off as x squared, and then minus 2x plus 1. So I'll say minus something something, and it goes on. So when I distribute this, see the x times x squared gives me the x to the third. So that's how I know I can't go higher than power 2 up here. So now we're going to write out our equation for f of x. We're going to say f of x equals, and we write out the first factor here, x plus 3, and we're going to leave it with just this power 1. And then the second factor, x minus 1, is going to have a square attached like this. So here's our equation for f of x. But remember, for this Regents, we can use a calculator. So I'm going to go over to y equals and type in, we have x plus 3. So I'm going to just write this nicely. We have x plus 3, and then times x minus 1 squared. And now I'm just going to press zoom 6 just to make sure the graph goes back to normal. And look at the graph that we get, and look at the picture they gave us. we could see here that this is matching up nicely. So our function is good. Question 30, given f of x equals 2/3 x plus 6, write the equation of f inverse of x. So anytime you want to find the inverse, what you want to do is you want to switch x and y and then solve for y. So what I mean by that is I think of this as saying y equals 2/3 x and then plus 6. So what we're going to do is we're going to take the x's and y's and we're going to switch them. Okay, so what I'm going to write next is x equals 2/3 y and then plus 6. And then once we switch x and y, we solve for y. So we can start by getting rid of this plus 6. We're going to go minus 6 on both sides. 6 minus 6 cancels, and we get x minus 6 equals 2/3 y. And now to get rid of the 2/3, what we could do is we could multiply both sides by the reciprocal of 2/3. So I'm just going to go times 3/2 on both sides. Okay, so times 3/2 on both sides. And now these terms cancel out. And we could say here y equals, and I could leave my answer like this. Okay, they didn't say to write your answer in the form of mx plus b or anything like that. So I can leave my answer like this. I don't get any extra points for distributing. But if you want to see this simplified here, we could distribute like this. And we're going to have 3/2 x and then minus, and just to think this through, if we do 3/2 times -6, I'm just going to do 3/2 times 6 first. And I like to do 6 divided by 2 is 3, and then 3 times 3 is 9. Okay, so we get minus 9 at the end. However, they said write the equation of f inverse of x. So don't leave your answer as y equals at the end. Actually write out f inverse of x like this, just so that you're answering the question exactly as they want you to. Okay, so those are annoying points to lose on a test like this. So just make sure that you follow the directions in the question. Question 31, on the coordinate plane below, sketch at least one cycle of the function f of x equals 4 cosine of 2x, and label the axes with an appropriate scale. So for this one, we have to know the anatomy of a trig function like this. Okay, so the 4 in front actually just tells us the amplitude. Okay, so we have an amplitude here. So we have an amplitude equal to 4. And we have no constant being added at the end. There's technically a plus 0 at the end. So what this tells us is that our midline, is going to be the line y equals 0, which is the x-axis. So when I label this graph here, I'm just going to put a 4 up here, and I'm going to put a -4 down here. Okay, so here, just think of it as I'm just jumping up here 4, -4 like this. So a good scale for this, I could count this part here by ones like this. And this should be good for the y-axis, right? Because our amplitude is 4. So we're just going to say here, this is 1, 2, 3. And then over here, we have -1, -2, -3. Now, the next part here, we have to be very careful of. The coefficient of x tells us the frequency. Okay, so this piece here, the 2, tells us the frequency. And the frequency here is equal to 2. Now, what that tells you is how many cycles the graph completes on the space from 0 to 2 pi, or over an interval of 2 pi. So before I actually start sketching this, I just think here for cosine like this, like a positive cosine, it's going to go like this. It's going to go from the maximum value to the midline, and I'll just abbreviate midline like this, to the minimum. Then it goes back to the midline, and then it goes back to the maximum. So it goes maximum, midline, minimum, midline, maximum. That's one full cycle that we're going to graph here. So what you need to know, though, the very important piece here for the x-axis is the period. And the period is equal to 2 pi divided by the frequency. Okay, so here we're going to take 2 pi and divide it by 2. And this tells us the period is equal to pi. And that's how long the graph is going to take to complete one full cycle. Okay, and we only have to graph one full cycle. So I'm going to say, let's say pi is going out to here. So another concept here is that this graph has 4 sections to it. So it has this part here going from the max to the midline, and then it has the piece here going from the midline to the minimum, and then it has this piece here going from the minimum back to the midline, and then finally the portion here going from the midline back to the maximum. So anytime I find the period, I like to divide it by 4 because there's 4 sections to the graph. Okay, so this is in a sense what I'm counting by. Delta x is really just saying what we're going to count by here. So we're going to count by pi divided by 4. So I break this into 4 sections here, and I'm counting by pi over 4. So if I count by pi over 4, I have 1 pi over 4, then I have 2 pi over 4, then I have 3 pi over 4, and then 4 pi over 4. And you could see 4 pi over 4, if I cancel out the 4s, just gives me the pi. So I would have here on the x-axis, I would have, let me just make this neater. So I would have pi over 4. And then 2 pi over 4 is the same thing as pi over 2. And then 3 pi over 4 would go here. And then 1 pi goes here. Okay, so that's how I would split this up here. And now I just go back to this thought bubble, and now I plot these points. So we have the maximum is at 4, okay, because we have a midline at y equals 0. So this is the midline here on the x-axis. And the amplitude is 4, so that puts us to a maximum of 4. So we're going from the maximum to the midline. So see, at pi over 4, now I go to the midline. And then at pi over 2, I go down to the minimum. So it's maximum, midline, minimum. And then back to the midline, and then back to the maximum when I'm at x equals pi. And now just carefully, I connect these with that cosine curve shape here. So I'm going to drop down like this. Then I'm going to drop down like this. Okay, so just make that part a little bit neater. So we're going to go down like this, and then swing back up, and then go up again. We just make that last part as neat as possible. So there it is. Okay, this is one full cycle of f of x equals 4 cosine of 2x. Question 32. In a recent online contest with a large number of randomly selected human players, the computer player won 67% of the time. The game design company claims that the company player can beat human players 70% of the time. The company runs a simulation of a large number of games with the same number of human players, assuming that the company wins 70% of the time. The simulation is approximately normal with a mean of 0.705 and a standard deviation of 0.045. Does the contest result provide evidence to contradict the designer's claim? Use the simulation results to justify your answer. So these questions have a whole lot going on. But when I read this, all I'm really thinking about is we have the mean plus or minus 2 standard deviations. Okay, this tells you where the middle 95% is, okay, our confidence interval. And the whole strategy with these questions is to see if the value that just showed up in the real world here, in this case here, the computer player won 60% of the time, is to see if that percent falls in this confidence interval. But it's based on the simulation. So here, the simulation, this is the part that we have to really use to build our justification here. The simulation is approximately normal with a mean of 0.705. So we're doing this, 0.705 plus or minus 2 standard deviations. And the standard deviation here was 0.045. So we're just going to use the calculator here to get our interval. So we're back on the main screen here, and we're just going to do 0.705. First, I'll do plus 2 times the standard deviation is 0.045. Okay, we press enter, and we get this value here. And now I'm going to go up to this, press enter, and just switch that plus to a minus, because it's plus or minus. And then these values are going to be the ones we need to answer this question. So now we can just write this out. So we have our confidence interval is going to go from the smaller number here. So we have 0.615. And then we have comma, our bigger number is going to be 0.795. And for this one, I would just reread just to make sure that we're rounding to the appropriate place. They didn't tell us what to round our interval to. So I just look out for things like that, because those are the annoying points that you could lose out on. So now let's think of this value here, the 67%. Well, 67% is the same thing as 67 out of 100. And 67 out of 100 is the same thing as 0.67. And I could always throw a 0 at the end like this. And now ask yourself, is this number here in between 0.615 and 0.795? And it is. So now I just read the question one more time or skim through it to see what's going on here. The game design company claims that the computer player can beat humans 70% of the time. And then they ran their simulation. And when they actually did the recent online contest, the computer player won 67% of the time. So this claim is reasonable because what we have here is that the recent online, a set of games here, the 67%, falls within this middle 95%. So this outcome here is reasonable based on what the simulation is saying here. So does the contest result provide evidence to contradict the designer's claim? This one, the language could be a little confusing, but we're going to say no here. Okay, the contest result does not contradict the designer's claim because this value 0.670 falls within the confidence interval. So now we're moving on to the part 3 questions. There's 4 questions here, and each one is worth 4 credits. Question 33, solve algebraically for x. And we have the equation 2 over x equals 2x plus 3 over x minus 4. And we have to express our answers in simplest a plus bi form. So for this one, what I like to do first is I like to say what x can't be. So since we have x's in the denominator, I'm going to note here for the first fraction, we can't have x equals 0 because then we would have division by 0. So this solution is just not possible. And if x minus 4 equals 0, that would occur when x is equal to 4. So we can't have x equal to 4 because once again, division by 0 is no good. Anytime you're solving a rational equation like this, you just want to be on the lookout for solutions that potentially could be thrown away. So I like to say this up front, so that way if I get to the end and one of these values pop up, I could just throw them away. But the fact that they're telling us a plus bi form is suggesting here that our solutions are going to be imaginary. So what we're going to have next is we have 2 over x equals 2x plus 3 over x minus 4. And then for an equation like this, one of the biggest concepts that you need is least common denominators. So the least common denominator between x and x minus 4 is x times x minus 4. So what I like to do is I personally like to multiply both sides by the least common denominator. But first, once again, I point out which x values are not possible. So here, I'm going to multiply the left side by x times x minus 4. And I'm going to multiply the right side by x times x minus 4. And what this does is it gets rid of the fractions involved. So notice here, x over x can now just cancel out. And on this side, we have x minus 4 over x minus 4 canceling out. So then the next line of our equation is going to be 2 times x minus 4 equals, and now we have x times 2x plus 3. So I'm going to write x in front times 2x plus 3. And now we just go ahead and solve this equation. So we distribute, we get 2x minus 8 equals x times 2x is 2x squared, and then we have x times 3 is 3x. And now we have a quadratic equation, so we should move everything to one side. Okay, so we're going to I'll move everything over to the right side here. So I'm going to go minus 2x on both sides. And I'm also going to go plus 8 on both sides. So now what we have is we have 0 equals 2x squared. And then 3x minus 2x is x, so we get plus x, and then plus 8. And then from here, what I'm thinking is I'm thinking of the quadratic formula. So the quadratic formula tells us x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So for this one, I noticed that when we're in the form 0 equals or quadratic equals 0, I could identify my a, b, and c values. My a value is my coefficient of x squared, which is 2. My b value here is equal to 1, and my value c is equal to 8. So now I'm going to say next, x equals, we have negative b, so we have negative 1 plus or minus the square root of, and now we have b squared, so we have 1 squared, minus 4 times a times c. And my a value is 2, and my c value here is equal to 8. And this is going to be all over 2 times a. I'm going to just make that a little neater, so over 2 times 2. So now for this stage of the question, I would type the discriminant, which is the term under the square root, right into the calculator. So we have 1 squared, and I recommend that you put parentheses for all of this. And I'll say why. For this first part here, when you're doing b squared, if your b term is negative and you don't, so let me just point this out. If let's say b was equal to negative 1. When I do negative 1 squared, I should get positive 1. But a lot of students will forget to put the parentheses, and they type it in the calculator like this, and it throws the whole question off. So if your b term that you're plugging in here is positive, then you don't have to worry about this as much. But just know it's good practice here to put parentheses when you're typing this in. Okay, so we have minus 4 times parentheses 2, parentheses 8. Okay, so this is going to tell us the term here under the radical that we should be getting minus 63. So now let's go ahead and close this out. We're going to have x equals, and then we have negative 1 plus or minus the square root of negative 63 over 4. So now at this stage of the question, we should be thinking about the square root of negative 1 is equal to I. So we could use that idea to start simplifying this. However, we do have to make sure at the end that our answer is in the form of a plus bi. Okay, so simplest a plus bi form is going to be important. So here, let's go ahead and write this out. So now for the next phase, we're going to have x equals negative 1 plus or minus, and the negative inside of a square root, I could just take outside like this and just say I, and then square root of 63 over 4. So then next, I'm just going to go ahead and write this in simplest form. So we're going to transfer over here. We're going to have x equals negative 1 plus or minus I, and then the goal here is to find perfect square factors of 63, and the biggest perfect square factor we have is 9. So we could break radical 63 up into radical 9, radical 7, and now this is over 4. So then that brings us to x equals negative 1 plus or minus, and then we have here, there's a few different ways we could write this. We could write 3 radical 7 and then the I after it, or we could even say 3i radical 7. Okay, the Regents will accept both of these. However, one thing we do have to do is split up and write this in the form of a plus bi. So what we want to do here for this last stage, and I'll just make space for our final answer, is we want to break this fraction up into 2 fractions. Okay, so this is the last idea that we need. And just know when you have something like this, like let's say I have p plus q over r, I'm allowed to write this as p over r plus q over r. Okay, so that's just a property of fractions that we could use here. So our final answer, we're going to say x equals negative 1 over 4, and then we have plus or minus, so let's make that neat, plus or minus, and then we have 3i radical 7 over 4. Okay, so this form here is acceptable and would get us full credit. Question 34, a highly selective college reports that the mean score earned by accepted students on the mathematics level 2 subject test is 750 with a standard deviation of 20, and that the scores are approximately normally distributed. Given this information, determine the interval representing the middle 95% of student scores. So the first thing we have to do here for the middle 95% is go take the mean and find the mean plus or minus 2 standard deviations. So here, this one we could do without a calculator. These numbers aren't too bad. So we have here, they told us that the mean, so the mean score on the test was 750. So we're going to do 750 plus or minus 2 standard deviations, and the standard deviation was 20. So really what this is telling us to do is we're just going to do here 750 plus 2 times 20, which is 750 plus 40, which is 790. And we're also going to do 750 minus 2 standard deviations. So we're doing minus 40 as well, which gives us 710. So our interval that we're going to go with here is going to be from 710 to 790. So this is the interval that represents the middle 95%. So next, to the nearest whole percent, determine the percentage of accepted students who scored a 760 or less. So for this one, what I'm thinking about is I think of a normal distribution curve. So I'm just thinking here, we have a normal distribution curve like this, and they told us that the average was 750. Okay, that was the mean. So I'm just going to think about that up here. So 750. The standard deviation was 20. So as I go forward 1 standard deviation, I do 750 plus 20 is 770. And if I go 2 standard deviations, that brings us up to 790. And then if we go backwards 20, so minus 1 standard deviation would put us at 730. And then minus another 1, so we subtract another 20, and that puts us at 710, which highlights the interval we did in the first part. But what they're asking here is what percentage of students scored a 760 or less. Okay, so determine the percentage of accepted students who scored a 760 or less. So you see how that's at the halfway point. So 1/2 standard deviation this way. So it's the percentage is everything here and backwards. Okay, so we want to know like what percent is covered here. But this is all done on the calculator, but I just want to point out that this is highlighting the concept of what we're actually finding. Like what percent of the space under the curve are we highlighting here? So for this one, we just press second vars. Okay, so we go here and we're going to go to normal CDF. Okay, so we're going to go to normal CDF. And for our lower bound here, well, how low of a score can we go with here? Well, let's just pretend here like someone got a 0, all right? But that's not going to be the case, right? This is a highly competitive college, but maybe they just got in, like someone they know donated $1 billion. So cool, now they're in. And then the upper part here is going to be 760. And then what we have the average and the standard deviation. So the average, they told us in the beginning, was 750. So we write our average in, and our standard deviation is 20. And now we just press enter all the way through, and this gives us everything we need. So for a question like this, I honestly just write out everything that I typed in the calculator. So I write normal CDF, and then I have 0, 760, 750, and then 20. And then equals, and I write out a few decimal places here. So I'm just going to write out everything that I see in the calculator. So we have, up to here. I'm just going to write out everything that I see on the screen. Okay, so just carefully writing these values down, but they said to the nearest whole percent. So this is where we have to know how to turn a decimal like this into a percent. So when you want to turn a decimal like this into a percent, what you're going to do is you're going to take this decimal. So I have this decimal here. And if I'm turning it into the nearest percent, so I'll just round it to this, I'm going to multiply this by 100. And I know I could stop here because when I multiply by 100, this decimal just moves 2 places to the right. Okay, so I have the decimal times 100, and then that's our percent. So this would be, if I move the decimal 2 places to the right, it would be 69.146%, but to the nearest whole percent, this would just be 69%. Okay, so this would be our answer. Question 35, for c of x equals 3x squared minus 4x plus 7 and d of x equals x minus 2, determine c of x times d of x minus d of x to the third power as a polynomial in standard form. So for this one, we're just going to go piece by piece. So we want to build up, we have c of x times d of x. We have c of x is here, and d of x is this part here. We're going to put in the expression in 2 places. So first I'll just build this up. C of x, we're going to have 3x squared minus 4x. I'll just make that a little neater. So 3x squared minus 4x plus 7, and we're multiplying that by d of x, which is x minus 2. And then we subtract. Now, they wrote this in brackets here, but parentheses are also fine, but I'll just go ahead and use their brackets. They have x minus 2 to the third power, okay? The reason they're doing this is at some point we're going to be doing x minus 2 squared inside here. So sometimes we'll use brackets when we have parentheses happening more than once. So brackets is acting the same way as parentheses will. So just to color code this so we could see c of x is this piece, and then we have d of x is here, and d of x is here again. But for something like this, what I want to do is order of operations. Okay, so my first thought process is order of operations. So we have PEMDAS, which tells us to do parentheses exponents, multiplication, division, and then we do addition or subtraction last. So here, parentheses exponents, I'm doing this part first because we have a power 3. So here, I'm going to call this, we're going on a side quest. You don't have to write side quest at your Regents, but we're going to do this first before we return to the main quest. So I'm just going to say here, x minus 2 to the third power. So we'll just write this out. We have x minus 2 to the third power. This is equal to x minus 2 times x minus 2 times x minus 2. And now I'll just expand this out here. So here, first I'm going to just multiply these two together. We have x times x is x squared. And then we have x times negative 2 is minus 2x. And then we get another minus 2x. And then we get a plus 4 at the end when we multiply negative 2 and negative 2. So we get here, and then we're still multiplying by that extra factor of x minus 2 at the end. Okay, so we get here. I'll just clean up this part first. So we're going to get now x squared minus 4x plus 4, and we're multiplying that by x minus 2. So now for the next line here, I'll just make this a little neater. So x minus 2. For the next line, now we're going to distribute the blue one here to the black one, all right? So we're going to multiply the quadratic by the linear factor. So here I'm doing x squared times x is x to the third power. And then I'm doing x squared times negative 2 is minus 2x squared. And then I'm going to distribute the minus 4x. So minus 4x times x is minus 4x squared. Then we have minus 4x times minus 2. we're multiplying a negative by a negative, so we get a plus 8x. And now for the last one here, we're going to do 4 times x is going to give us plus 4x. Just make that a little bit neater, so plus 4x. And then we have 4 times negative 2 is minus 8. Okay, and I'm just going to move that over so that it all stays, in the boundary here. Okay, so we're going to be over here. And now I just clean this up, combine like terms. So we have x to the third. And if I do minus 2x squared minus 4x squared, that makes minus 6x squared. I'm just doing negative 2 minus 4. And then I do these two. 8 plus 4 is 12, so I get 12x. And then I get minus 8. So now I could write out my next line here. So what we're going to have is after the minus sign, so over here, the minus x minus 2 to the third, I'm going to write over here, we're going to have minus, and then what we have here in red. Okay, so we're going to have minus, and then we have x to the third, minus 6x squared, plus 12x, and then minus 8. So I'll just shrink that side quest and make space because we're going to have a lot to write over here. So now for this part over here, we also have to distribute and multiply these two expressions together. Okay, so that's what I'm going to write over here in this parentheses. So we're going to have, I'm going to write this out one by one. We have 3x squared times x is 3x to the third power. And then we distribute again. So we go here, we have 3x squared times negative 2 is going to give us minus 6x squared. And then next I'm going to send the minus 4x through. So we do minus 4x times x is minus 4x squared. And I'm going to move this over in a moment just to make space. And next we'll do minus 4x times minus 2 is plus 8x. But now let me just make a little space for us. All right, that should be good to close this out. So then next, so we distributed the negative 4. We got minus 4x squared and then plus 8x. But now we have to distribute the plus 7. So we have 7 times x is 7x. And then we have 7 times negative 2 is minus 14. So then in the next line here, what I'm going to do is combine like terms. So we're going to have here in the first parenthesis, 3x to the third power. We have minus 6x squared minus 4x squared is minus 10x squared. And then we have 8x plus 7x is 15x. And then minus 14. And we have minus, and then in the next set of parentheses here, we still have the x to the third, minus 6x squared, plus 12x, minus 8. And then from this point on, we just have to be careful. The next thing I'm thinking about is the process keep, change, change. Okay, when you're subtracting polynomials, you could keep the first polynomial the same. You change the operation to addition, and then you change the sign of all the numbers inside the second set of parentheses. So here, what I'm going to do is I'm going to write out, we have 3x to the third, minus 10x squared, plus 15x, minus 14, and then once again, I'm changing this operation to addition. So I have plus, and then I change the sign of everything here. So I have minus x to the third, and then I have a plus 6x squared, and then I have a minus 12x, and then I get a plus 8 at the end. Okay, so I'm just doing this. And the reason this process works, so I'm just make that a little bit neater. So the reason this works is we're basically using the distributive property. We're sending the negative through, which is changing the sign of the second polynomial. Okay, so now I just have to be careful here and go piece by piece. I like to do this vertically to line up like terms, kind of like doing long addition in elementary school. So here, 3x to the third plus negative x to the third is like doing 3 minus 1 is 2. So I get 2x to the third power. And then here we have negative 10 plus 6 is negative 4, and then I bring down the x squared. 15 minus 12 is positive 3, so I get plus 3x. And then negative 14 plus 8 is negative 6. And then here is the polynomial in standard form. Question 36, Christopher works for a defense contractor and earns $85,000 his first year. For each additional year, he will receive a 2.5% raise. Write a geometric series formula C sub n for Christopher's total earnings over n years. So for this one, we could go to the back of the Regents and get the geometric series formula. So we have S sub n equals, and then we have a sub 1 minus a sub 1 times r to the n divided by, and then we have 1 minus r. And one thing to note here is that r cannot be equal to 1 because then we would have division by 0, and that wouldn't be good. Okay, so this is the formula we're going to use here. However, they're telling us to name it C sub n. And I'm guessing because Christopher's name starts with C, so they want the alliteration here. So we're going C sub n. But we just have to find each of these pieces. So A1 is the first term of the geometric series, and that's going to be based on how much he earns in his first year. Okay, so 85,000 is going to be A sub 1. And then each year he receives a 2.5% raise. However, we have to be careful with this. We have to think about how do we account for this raise. We want to think back to, and I'm just draw this a little bit bigger, but think back to the Algebra 1 days where you had this formula. So A equals P times 1 plus or minus R to the T power. Now the Algebra 2 version is when we compound, quarterly or semi-annually. So ours is a little more complicated, but the Algebra 1 version is very relevant here, that when we want to find out what we're multiplying by, we're actually going to take our R value to be 1 plus. Okay, so the 1 plus, because he's getting raises, so his pay is going up. So we're seeing here for our geometric series, what are we multiplying by to find his new salary each year? So a 2.5% raise, we would say 1 plus 2.5%. Okay, so 1 plus 2.5%. And if I do this, R equals 1 plus 2.5 out of 100, which is the same thing as saying 1 plus 0.025. So this will tell us R is equal to 1.025, okay? But if we want to just get to this step here, we don't have to include this part here. I'll just make space, okay? I'm just going to say here that our R value is going to be 1.025. A common mistake is students just take R to be 0.025 and forget to add it to 1. You just have to think of that compound interest idea from Algebra 1. So now I could set our formula up. We're going to call it C sub n equals A1 is 85,000. And then we're subtracting 85,000 again, but this time times R, which is 1.025 to the power n. And we're dividing by 1 minus R is 1 minus, and then we have 1.025 like this. So next they're telling us to use this formula to find Christopher's total earnings to the nearest $100 over his first 10 years of employment. So here, now all we have to do is just plug in 10. But I want us to understand the concept of what's going on here. So that way it's not just use the formula and memorize what's happening. The concept of what's going on is we know that Christopher earns $85,000 his first year. But then his second year, he earns 85,000 times 1.025. And then his third year, so first year, second year, third year, and his third year, what's going to happen is he's going to earn another 2.5% raise, but that's based on the previous year. So when we multiply by 1.025 again, we get 1.025 squared. Okay, but what's going on in this question is we're adding everything up. They're asking us how much does he make in total? Okay, so use the formula to find his total earnings. So we're adding this all up, but we're stopping at his 10th year. Okay, and this formula will tell us what that sum is, so we don't have to type this all into a calculator one by one. That would take quite a long time. Although we could just factor out an 85,000 and just do it that way, but they're telling us use the formula. So we have to use the formula here. We're not allowed to just do this by brute force in the calculator. So here we're going to say 10 years of employment is telling us to plug in n equals 10, which is going to give us C sub 10. See, I'm replacing the n over here with 10. C sub 10 equals, and then we have 85,000 minus 85,000 times 1.025 to the power 10, and we're dividing all of this by 1 minus 1.025. So this I typed right into the calculator. If you have a newer calculator, you can just press alpha x to pull up a fraction. Otherwise, you press alpha y equals enter to pull up a fraction. And I recommend you do this so that you don't make a typo. This reduces your chances of making a typo. So we have 85,000 and then minus 85,000 again. But now parentheses, we have 1.025 and now to the power 10. And then to the denominator, 1 minus 1.025. So we do this, and this is the value we're getting. So now we're going to write our answer out. We could say C sub 10 is roughly equal to, and we're finding his total earnings. So here, they told us to round to the nearest $100. So I just want to point out that here we have the ones place. Then next we have the tens. And then after this, we have the hundreds. Okay, so we have the hundreds place. right after. So for this one, when we're rounding to the nearest hundreds, we're going to go here in the hundreds place, we have a 2. To the right is an 8, so we're going to round up. We're going to round up. We're going to have 952, and then we're rounding the 287 here up to 300. Okay, so we're going to round up like this. Okay, so C sub 10 is roughly 952, 300. But then if I wanted to write it out here, formally, I would say, let me just make that a little bit nicer. So with the dollar sign, we're going to have 952,300. Okay, so this would be the approximate to the nearest $100 earnings for Christopher in his first 10 years of employment. So now we're moving on to part 4, the final boss, and this question is worth 6 credits. Question 37, cesium 137 decay can be modeled with the formula A of t equals A naught times e to the kt, where A of t represents the mass remaining in grams after t years, and A naught represents the initial mass. A sample of 500 grams of cesium 137 takes approximately 60.34 years to decay to 125 grams. Use this sample with the given formula to determine the constant k to the nearest thousandth. So for this one, what we want to do is just go piece by piece and define the terms that we could then plug into this formula to solve for k. So this, they tell us a sample of 500 grams. Okay, so we're starting off with a sample of 500 grams. So that tells us A naught is equal to 500. And then next they tell us that it takes approximately 60.34 years for the cesium to decay to 125 grams. So here what that tells us, when t is equal to, we have 60.34. So when this happens, we're going to have an amount here, A of t, of 125. All right. Now, the technical way to write this is to say A of 60.34. Okay. Because the function is called A of t. So the amount at this time is equal to 125. All right. But when we just plug into the formula, we don't even have to define the variables like this. You can just plug in reading this and then just start plugging in and solving. So the goal here, of course, is to find what is the value of k. All right. So that's what we want. So now we just plug this stuff in. So what we have here, A of t, the amount at this time is 125. So we have 125 equals A naught is 500, and we're multiplying by e to the k times t is 60.34. Okay, so we're solving this equation for k. So the first thing we could do here is just divide both sides by 500. Okay, so I'm going to go divide by 500 on both sides like this, and we get 125 over 500 is equal to, and then we have e to the 60.34 times k. All right, so this is what we're doing here. And for this one, I'll show another way to do this later, but I'm doing this algebraically. So then to get rid of e, we have to think of the opposite of e. And the opposite of the function e is natural log. So I could take the natural log of both sides. So I'm going to take the natural log of this side, and I'm going to take the natural log of this side. And then in the next line here, what we're going to have is we're going to have natural log of 125 over 500 equals, and now natural log and e basically just cancel out like this, and we're left with 60.34 times k. So to solve for k, we just divide both sides by 60.34. And then from here, we're going to get our k value here. Okay, so k equals, and we'll just type this in the calculator. So I'm going to press alpha y equals enter again just to pull up a fraction. We have natural log of 125 divided by 500. And then underneath, we're dividing by 60.34. So we press enter, and we're going to get this for our k value. They said to round to the nearest thousandth, so we would have negative 0.023. Okay, that's going to be our k value. Now, they didn't say to determine this algebraically. So let's say we get to the equation step and we're like, oh no, how do I solve for k? So what we could do for something like this is we could type in the left side, 125, and then the right side of the equation was 500, e, so second natural log, and then k, I'm just going to put x because that's the variable button for the calculator, and then multiplied by 60.34. But since y1 is equal to 125, I would go to the window and make sure my y maximum goes past that. So I'm going to go up to, let's say, 150. And now I press enter, and you see how we have this point of intersection here? I press second trace number 5 to see where these intersect. Press enter 3 times and see how we get that same value here. Okay, so either way, we're going to get the value that we need. If they say algebraically though, then I have to show all these steps. But if they just say determine, you could just do a little sketch and say the intersection point here in the calculator, and that would suffice as work shown. So we'll just write this out. Our k value is going to be negative 0.023. Okay, rounding to the nearest thousandth. In the thousandths place, we have a 2. To the right is a 9, so we're going to bump this up to a 3. And this is the k value that we need. So now for the second part of this question, use this value for k to write a function a of t that will find the mass of the 500-gram sample remaining after any amount of time t in years. So now for this, all we have to do is just plug the values into the main formula. So we have a of t equals a naught is equal to 500. And now we're going to have e to the kt power. And k, that what we found in the first part, was negative 0.023. And then we just multiply by t. So this is going to be our function here. And once again, they're saying to write it so that we could write it as a function of time, so that we could find the sample remaining after any amount of time t. So the formula at the end should be in terms of t. And we could use this formula to say how much cesium-137 there is at any time. For the next part of this question, we have to graph a of t on the graph below from t equals 0 to t equals 150 years. Now, before I use the calculator, I just want to see how much space we have on the t-axis. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 spaces. So my thought process when I'm making my scale is if I'm going from 0 to 150, and I have 20 spaces to go, if I divide here, that's 7.5. But if I do 7.5 times 2, that's 15. So what that means is I could skip every 2 spaces. I could count by 15. So I could go 15, then 30, and so on like this. Okay, so I could just count up like this. And that's going to make our scale really nice for this question because I don't want to make it too squished. Let's say I count by tens or something, then the graph is going to be really squished. It's fine if I do, but for me, I just prefer to draw this here as big as possible and take up the whole space that they give us. Okay, so I'm just counting by 15s, and if I did this right, we should end at 150. So we have 135, and then 150 here is at the end. Now, we are also noting here that we're starting out with 500 grams. So in this direction also, we have 20 spaces, okay? So they gave us a nice square grid here. So for the y-axis or the a of t axis, I'm going to take 500 and divide by 20. I just cross off a common 0. And this tells me I could count by 25s. Or I'll just skip every space and count by 50s instead. So I have 50 and then 100, and I'll do this up to 500. So now let's go ahead and type this in. So we have y equals, and then in the y equals spot here, I'm just going to write in our function. So we're going to have 500. And then we have times e, so second natural log, to the negative 0.023 t, but I'm going to use x. And then for our window, we're going from 0 to 150. And our y values are going to go from 0 up to 500. Okay, if we do this, we can see we get this nice exponential curve here. But now I'm going to press second graph here to go to the table. And you might think, oh no, it's going to take me forever to scroll to 150. But just know what you could do is you could press second window and you could change your independent from auto to ask. And then when you go to your table, you can make a custom table here. Okay, so then I could just type in these values. I could do 0, I could do 15. I just type it in and press enter. And I just keep doing this all the way until the end, okay, until I get to 150. So now I'm just going to plot these points, getting as reasonably close as possible. Now, just one thing I want to mention for accuracy, they're not going to break out a magnifying glass here and see that you're like ultra precise. However, something like, let's say 45, 177. So here, notice between 150 and 200 is 175. So when I was graphing that point, I was going a little bit above 175. So once again, as long as you're in the neighborhood, you'll be okay for the graph. So this graph here would get full credit. So now for the next part of this question, they want us to use A of t to calculate the average rate of change in grams per year from t equals 0 to t equals 60 years to the nearest tenth. So we're finding the average rate of change, which is telling us to find the slope between this point here and this point here when t is equal to 60. So for this, if I'm writing it in function language here, what I'm finding is I'm finding a of 60 minus a of 0, and then I'm dividing by 60 minus 0. And later on, we're going to have to explain what this value means in the given context. So for this one, if we're going to have to explain what this means in the given context, what I want to look at is the units that they told us. So they told us the average rate of change is in grams per year. And that makes sense because in the beginning of the question, if we go back for a moment, they told us that A of t represents the mass in grams and t is the number of years. Okay, they told us later, once again, that t was the number of years. So that's where grams per year is coming from, that the y-axis is measuring grams and the t-axis here. So the x and y-axis is the t and A of t axis. So we have grams and then per year. Okay, so that's how we're going to be measuring this when we actually work this out. Now, one thing I want to point out is we could just go ahead and grab these values from the table and just do this decimal here minus 500 and then divided by 60 minus 0. But there's something else we could do on the main screen. If you don't know this trick, it's a pretty nice trick. Alpha y equals enter. You could just write here, we saved A of t in the y1 spot. So I could press alpha trace y1 and then do parentheses 60. And this will read as A of 60. And then minus the function value. So we have y1 again, but this time at 0. And we're dividing by 60 minus 0. So this is just a cool way that you could type function values right in the calculator. And this is going to give us to the nearest tenth, negative 6.2. However, if you just wanted to go to the table and use these values here, so we could just go alpha y equals enter and just type in 125.79. So that was the y value when t was 60, or the A of t value, we should say, and then minus 500 divided by 60 minus 0 is 60. See how to the nearest, we're rounding to the nearest tenth, so we're using one of the rounded values, but we're still going to get negative 6.2. So we'll just write out our final answer here. We're rounding to the nearest tenth. So in the tenths place is a 2, to the right is a 3. So this is going to round down to negative 6.2, and the units here are grams per year. And now in the last part, we have to explain what this value means in the given context. So remember, this function was modeling the decay of cesium-137. So what we just found here was the average rate of change. So what this is telling us is that cesium-137 is decaying at an average rate of 6.2 grams per year from t equals 0 to t equals 60 years. It's very important when we write our explanation that we include the time range here in which we're calculating this average. Now, one thing I want to point out before we close this out, notice that in the sentence here, we're saying that the cesium is decreasing at an average rate of 6.2 grams per year. But when we found our average, we got a negative 6.2. So a negative average rate of change is telling us, based on what we're looking at here, that our function is decreasing over that space. Like over time, once again, since we're dealing with exponential decay, it's telling us the average rate that the function is decreasing. So I just say the number without the negative here when I'm writing my sentence. The decreasing is what accounts for the fact that our average rate of change is negative.